Okay, good afternoon to all. Welcome you all for this today's lecture of non-conventional machining. Whether my voice is audible? I am audible? Okay, okay. Screen is visible to all? Okay. Now, in last lecture, we have covered what is a non-conventional machining. Before that, we discuss on a basic primary manufacturing process, secondary manufacturing process, then what is a conventional machining, what is a non-conventional machining. Then we discuss why we need to study such a non-conventional, non-traditional, or we may call it as a advanced machining processes. Now, in today's lecture, we will focus on the next point of the chapter, that is how will you classify this non-traditional machining processes. Means, in this lecture, we will discuss how you have to classify the non-conventional or advanced manufacturing process. That is nothing but you have to classify this processes. Within a short period of time, we'll take a recap. In yesterday's lecture, last lecture, we see that manufacturing process, it will be divided into mainly two types: primary manufacturing process, which will provide basic size and shape. Its example is a casting, forming. Second type of the manufacturing process is the secondary manufacturing process. It will provide the final shape and size to the workpiece or material with a high degree of accuracy and a high degree of a surface finish. That is a surface characteristics. Such processes are called as a secondary manufacturing process. Whatever the material removing process you have studied earlier, all such processes are come under the category of the secondary manufacturing process that we have covered in last lecture. Also, we are focusing on whatever the material removal processes we have studied earlier in last year in manufacturing process subject. They are broadly divided into two types. That is the conventional machining process and non-conventional machining process. The conventional machining process, in such processes, we are removing the material from the workpiece by applying the cutting force by using the cutting tool against the workpiece. And whatever the material is to be removed, it is in the form of chips. To remove the material from the workpiece, the main requirement is that the material of the tool, it must be harder than the material of the workpiece. Which are such conventional machining processes? You know, turning process, drilling process, boring process, grinding process. Such are some of the examples of conventional machining process, where there will be a physical contact between workpiece and the tool material. But secondly, hello, no one is remain outside the classroom, outside the meeting.
Sir, someone are outside. Please allow them.
Admitted all. I think no one is outside. Sunil? Hello? Okay, I think no one is outside now. Because I make the setting that no one will be remaining outside the meeting. Automatically, they will be get entry in a lecture. Okay. Is it clear? Hello?
Yes, sir.
Okay. Now, the second type of the material removing process, that is a non-traditional machining process. In such process, we are removing the material from the workpiece in the form of small atoms or small particles, and there will be no necessity of the tool to remove the material from the workpiece. Also, there will be no need to have a physical contact with any any imaginary tool with the workpiece. So such machining processes are called as a non-traditional machining processes. They are removing the excess material from the workpiece by utilizing the different techniques which involves certain kinds of the energies. It may includes mechanical, thermal, electrical, chemical, or combination of such energies. But they does not require a sharp edge cutting tool in order to remove the material from the workpiece that was used in a traditional machining process. Which are those such machining? It may consist of abrasive jet machining, that is AJM, electric discharge machining, EDM, LBM, that is a laser beam machining, and electron beam machining. Now, this will be the major characteristics of conventional and non-conventional. If you are considering the conventional machining, in which whatever the material is to be removed, it is in the form of chips, and these chips are मॅक्रोस्कोपिक इन नेचर. मॅक्रोस्कोपिक म्हणजे काय? आकाराने थोड्याशा मोठ्या असतात, जे डोळ्याने दिसतात, त्याला काय म्हणतो आपण? मॅक्रोस्कोपिक चिप्स that will be formed by using in case of the non-conventional. Also, application of the cutting forces is required. Means, in order to remove the material from the workpiece, you have to give a feed or cutting force to the cutting tool against that workpiece. Then and then only the material is to be removed from the workpiece. Means, application of the cutting force it is necessary in order to remove the material from the workpiece in case of the non-conventional machine. And one important parameter, that is a characteristic, whatever the tool you are using, its material must be harder than the material of the workpiece from which you have to remove the material. These are the three main characteristics of the conventional machining process. That is, first one, microscopic chip formation. Second one, application of the cutting force. And third one, that is a cutting tool. It must be harder than the workpiece. Next point, there are certain characteristics. Those are the major in case of the non-traditional or non-conventional machining process. Whatever the chips or material is to be removed from the workpiece, it is in the form of small atoms or particles. There will be no chip formation in case of a non-conventional machining. Also, there may not be any physical tool. It will be present in all types of the non-conventional machining. As like we require a sharp edge single point cutting tool during the turning operation on a lathe machining. It is an example of a conventional machining process. But in case of the non-conventional machining process, we may not require any kind of the physical tool. If tool is not required, then there will be no matter of its hardness. The tool need not to be harder than workpiece. If any one of the non-traditional process, it will require a tool. A tool is nothing but one kind of electrode. We will say in a electrochemical machining process, right? Tool is nothing but one kind of the electrode, and it is having the shape like which shape you have to produce on a workpiece. That same shape that electrode or that tool it is having. So if there will be a requirement of the tool, but that material of the tool, it will not necessary to be harder than the material of the workpiece. Where in a non-conventional machining process, we require different forms of energy, direct and indirect forms of energy, in order to carry out the machining process. Means, in case of the non-conventional machining process, these are the some major characteristics that show that such kind of the machining processes are come under the category of the non-conventional machining. Which are those? There will be no formation of the chip. Tool may not be required. It will not necessary to have a tool more harder or more hardness than the material of the workpiece, and such kind of the machining it may require different forms of the energy domain in order to remove the material from the workpiece. You may write such these major characteristics of conventional as well as non-conventional machining. Make a point of this. Okay. Also, in last lecture, we focus on a need for non-conventional machining. That is complicated shape or intricate shape blind holes, sphere shape hole with a certain depth that will be not drilled by using the conventional machining. Such holes can be drilled by using the non-conventional machining. There are certain materials, those are having very high hardness. Such kind of the materials can be machined by using the non-traditional machining like titanium alloys and carbides. Machining of such material is quite difficult in case of a non-conventional machining. If we are considering the grinding process where we require the low stress, because stress will affect the mechanical properties of the workpiece. So chemical grinding, it is one of the method by which electrochemical grinding, it is the method of a non-conventional machining. Electrochemical grinding, it is a method of a non-conventional machining it will be more suitable as compared to the conventional grinding process because it will produce less stresses on a workpiece material. We can drill the hole with a very small diameter, that is a 1.5 mm diameter hole can be drilled by using the non-conventional machining process. Also, we can machine the different types of the composites by using the non-conventional. Means this slide it will represent these are the certain areas or applications where conventional machining processes are have certain limitations. Because of that, we need the non-conventional machining process. So this slide it will represent why we need the non-conventional. Now, main point of today's discussion, that is the classification of non-conventional machining process. Because in previous slide we discussed on that in order to remove the material from the workpiece, non-conventional or non-traditional machining processes they are required different sources of energy. It may be a direct or indirect source of energy. Which are the sources of energy? It may based on mechanical energy, thermal energy, chemical energy, and combination of this. So, according to the source of energy used to generate the machining action in case of a non-traditional machining process, these processes are classified as a mechanical machining process, thermal machining process, electrochemical machining process, and chemical machining process. Right? If we are considering the chemical machining process, in such mechanical machining process, in such kind of the process, we are removing the material of the workpiece from the workpiece by the process of erosion. Means because of the erosion, material is to be removed from the workpiece, and that erosion is to be carried out by using high velocity of the fluid or high velocity of the abrasive or combination of this. What is abrasive? Abrasives are the small conical metal particles, sharp edge conical metal particles. They are bombarding on a workpiece with high velocity. When such abrasive particles strikes on a material of the workpiece, they are removing the material from the workpiece by the process of erosion. Means, if you are classifying this non-traditional machining process based on a mechanical energy in which material is to be removed by the erosion of the work material, and it will be happen because of a high velocity stream of the abrasive or fluid. It will be impinging or impacting or striking on the surface of the material of the workpiece. In short, if you are classifying non-conventional energy based on a mechanical energy, that machining processes are called as mechanical non-traditional machining processes or non-traditional machining processes based on mechanical energy. Non-conventional machining processes based on mechanical energy. It may include ultrasonic machining, it may include abrasive jet machining, water jet machining, or combination of these two. That is the abrasive water jet machining. In all this type of the machining process, the material is to be removed from the workpiece because of the action of the erosion. Means all type of the non-conventional machining processes based on a mechanical energy where material is to be removed from the workpiece by the process of erosion. Are you getting first type? Yes, reply. Hello.
Yes, sir.
Okay. Then second type of the non-conventional machining process is based on a thermal energy. Thermal, it means heat, right? So by using the heat, we can remove the material from a particular part of the workpiece. So in case of the thermal energy based non-conventional processes, the thermal energy is to be applied on a very small or a very appropriate part or portion of the workpiece. It will causes a removal of the material from that particular area, particular portion by the fusion or by the vaporization of the material. And this thermal energy or heat energy, it is to be generated by conversion of electrical energy into heat energy. Means, in case of the non-traditional machining processes which are based on thermal energy, the material is to be removed from the workpiece due to the action of the heat, and that heat, it will cause melting and vaporization of the material from a particular portion of the workpiece, and that heat or thermal energy is to be obtained by the conversion of a electrical energy into heat energy or thermal energy. Now third type of the classification or the non-conventional process, that is the electrochemical machining. That is nothing but you have studied the electrolysis process in 12th, right? This mechanism, it is a reverse of a electroplating process, anode to cathode, cathode to anode. When there are two electrodes placed in an electrolytic solution, electrolysis, and we are passing the current or we are applying the voltage across these two electrodes, the material is removed from anode to cathode. So such a way that, or cathode to anode in such a way that coating is to be formed on a workpiece or material is to be removed from the workpiece. So it is a combined action of chemical as well as electrical energy. So such processes are called as a electrochemical machining, right? It may consist of EDM, electro discharge machining, right? Then next type of the or next classifying criteria for the non-conventional machining process, that is the chemical energy. Means the material is to be removed from the workpiece by the chemical reactions of any agent or acids you are using in order to remove the material from the workpiece. Means there will be a reaction is to be carried out between the chemicals and the material of the workpiece. Because of that chemical reaction, material is to be removed from the workpiece. Most of the materials, those are susceptible to chemical attack by certain acid and other agents. They are used, they are utilized, or such materials are to be utilized to remove the material by the process of a chemical non-conventional machining process. In chemical machining processes, chemicals are removing the material from the portion of the work part, while the other portion of surface is to be protected by the maskant. That is nothing but if you are considering the chemical process where the portion of the workpiece from which material is to be removed, it is only open to the chemical. Other portion of the workpiece, it will be covered with maskant. Maskant, it is a one kind of a insulator that cannot allow the contact of a chemical with the work material. So whatever the portion from which you have to remove the material from the workpiece, that only exposed with the chemical. Chemical, it may be a etchants or acids. So for that particular portion, chemical reaction is to be carried out and material is to be removed. The other portion of the workpiece, that will be covered with maskant. Maskant is mask. It will be a insulator that will not expose the surface of the workpiece with the chemicals, right? So we can classify the non-traditional machining processes based on a type of the energy source which is used to remove the material from the workpiece. So we can classify in four main types, that is a non-conventional or non-traditional machining processes based on mechanical energy, first based on thermal energy, second based on chemical energy, third and based on electrochemical energy, that is the fourth. These are the classification of the non-conventional machining processes based on energy. If you are considering non-conventional machining process based on mechanical energy, which are those processes? Abrasive jet machining, ultrasonic machining, water jet machining, and abrasive water jet machining. If you are considering the combined effect, thermoelectric machining, then the non-conventional machining come under the category of a thermoelectric machining. It will be plasma arc machining, laser beam machining, electron beam machining, electric discharge machining, and ion beam machining. So these are the combinations of the two energy, thermal energy and electric energy. If you are only considering the thermal energy, then plasma arc, laser arc, electron beam, and ion beam machining. If you are making a combination of thermal plus electrical, then it will be a electric discharge machining. Electric discharge machining, it is in short called as a EDM. If you are considering the electrochemical and chemical machining process, then it will become there are certain types of the machines come under the heading of electrochemical and chemical machining, that is the electrochemical machining ECM, and chemical machining, that is the ECHM. These are the two types of the electrochemical machining. These are the certain finishing processes: abrasive flow finishing, magnetic abrasive finishing. It does not include in your syllabus. As far as mechanical machining is concerned, abrasive jet machining, water jet machining, abrasive water jet machining, and ultrasonic machining. Thermoelectric is to be concerned, plasma arc, laser beam, electron beam, ion beam, electric discharge machining. And chemical and electrochemical, there will be chemical machining and electrochemical machining. Make a point of these all types of the non-conventional machining processes based on these three types: mechanical, thermoelectrical, chemical, and electrochemical. इन शॉर्ट मध्ये पॉइंट लिहित चला शिकवताना ज्यावेळेस शिकवतो त्यावेळेस इज इट ओव्हर ओके नेक्स्ट If we are considering mechanical machining process, see here. This diagram is a self-explanatory. Any problem? Okay. Uh, Screen is visible clearly. Hello. स्क्रीन दिसते का व्यवस्थित पिक्चर डायग्राम व्यवस्थित
हाँ सर
दिसते ओके the first type of classification of a non-conventional machining process that we have discussed earlier, that is a mechanical energy based non-traditional or non-conventional process. Here we took two examples, ultrasonic machining and water jet machining, right? This is the workpiece. This is the type of the non-conventional machining process. You have to remove the material from this workpiece, surface of the workpiece. इथून तुम्हाला मटेरियल रिमूव्ह करायचं आहे. To remove that material, what you required? In case of ultrasonic machining process, you require the abrasive particles, right? You require the abrasive particles, and abrasive particles are nothing but the small tip-shaped metal particles or conical particles, right? And when they are attacking on a surface of the workpiece, the material from the workpiece, it will be removed. And to carry out that removed material, you require the fluid, and that is called as a slurry. Means abrasive plus fluid or water, it will be called as abrasive slurry. It will be impinged on the workpiece. So whatever the material is to be removed from the workpiece, it is because of a action of erosion, and that erosion action is to be carried out by the abrasive particles in case of a ultrasonic. If we are considering the water jet machining, no doubt we have to remove the material from the workpiece. To remove the material from that workpiece, we require certain kind of the cutting force, and that cutting force is obtained by using the high velocity water jet, and that high velocity water jet, it will be strike on surface of the workpiece, so that that high velocity water jet, it will remove the material from the workpiece. So these are the two examples we have studied in case of the mechanical energy based non-traditional machining process. Mechanical machining process. Which are one? First one, ultrasonic machining, that will require the abrasive particles to remove the material from the workpiece by the action of the erosion. Same in case of water jet machining, we require the high velocity water jet in order to remove the material from the workpiece. समजतंय का हे? एक आयडिया क्लियर होते? What we have discussed over here? In ultrasonic machining and water jet machining are the examples of a non-traditional mechanical process. The machining medium is a solid grain suspended in an abrasive slurry. In the former, means in ultrasonic machining process, we are using the abrasive slurry, and in water jet machining, you are using the fluid as a cutting working medium, right? So this is the example of the mechanical energy based non-traditional process. Just draw the block diagram. Mechanical energy based non-conventional machining process. How material is to be removed, it will be shown diagrammatically for ultrasonic machining process and water jet machining. Okay, is it clear? Next, thermal machining process. This diagram, it will clear your concept how material is to be removed by using the thermal energy based non-traditional process, non-conventional or advanced machining process. In which type of the processes we require the thermal energy or heat energy? The first type, that is the EDM, electric discharge machining. Second, we may PBM, plasma beam machining. Third, EBM, electron beam machining. IBM, ion beam machining. And LBM, that is the laser beam. This is the type of the non-conventional machining process. No doubt, this is the workpiece for all these processes. If you are considering electric discharge machining as a process, where we require the electric current, and that electric current, it will generate the plasma, and that plasma, it is having a very high amount of heat, and to complete that circuit we require the dielectric field, and it will be circulating over this workpiece. So in case of a electric discharge machining, you require the dielectric fluid, and the electric energy is converted in a plasma. Plasma arc is there, and that arc is having a very high temperature, and because of that heat of that arc, it will be utilized to remove the material from the workpiece by melting it or by vaporizing. So in electric discharge machining, we require the thermal energy to remove the material from the work. Same in plasma beam machining, we require the plasma, and it will be produced by plasma beam, and material is to be removed from the workpiece. If you are considering electron beam machining, we require the electrons, and material is to be removed from the workpiece, and electrons are to be produced by using the electron beam machine in the form of electron beams, and that electron beams are strike on the surface of the workpiece. But in case of a electron beam machining process, the workpiece must be kept in a vacuum. Here, this. What it shows? The condition of the atmosphere where that machining process is to be carried out. In case of electric discharge machining, you require the dielectric field. In case of electron beam machining, you require the vacuum where you can put the workpiece. In case of a plasma beam machining process, you require the gas or air where you can mount the workpiece. Now next one, that is the ion beam machining, where like a electron, you require the ions, and that ions, it will be formed from the beams, and that ions must be impinging or strike on the workpiece so that they will remove the material from that particular area of the workpiece, and that workpiece must be kept in a vacuum. In multiple choice questions, they may ask which of the thermal machining process that will require the vacuum. So if options are given, the correct option, that is the electron beam machining or ion beam machining. Last one, that is the laser beam machining. In case of the laser beam machining, the material from the workpiece, it will be removed because of the photons. and that photons are produced because of the laser beam, and that photons are allowed to strike on a workpiece in atmosphere of the air. Means workpiece is mounted in a open atmosphere which will be surrounded by the air. When this laser beam it will be strike on a workpiece, heat is to be generated and the material is to be removed by the melting as well as vaporization, because the temperature it will be achieved very high because of the striking of the laser at a particular portion on the workpiece. Whatever the processes we have studied under this thermal non-traditional machining processes, the material it will be removed from the workpiece because of the thermal energy or heat energy, and that thermal energy or heat energy it will be the obtained because of the conversion from electric. Okay, this is the thermal non-traditional machining process. I will take a recap. That is the EDM. It will require dielectric fluid and the material is to be removed because of the plasma beam machining. It will require the gas surrounded to the workpiece and material is to be removed because of the plasma. If you are considering this EBM, electron beam machining, it will require the electrons to remove the material from the workpiece, and the medium required it will be the vacuum. Similarly, for the ion beam machining, ions are required to remove the material from the workpiece in a vacuum atmosphere. In case of a laser beam machining, photons it will be produced from the lasers. So, as the laser gets activated, photons are produced, and that photons are removing the material from the workpiece in atmosphere of the air. Just to draw the diagrams of this thermal non-traditional machining process within a minute. Block diagram. Okay, from this slide, your concept may be clear that these are the certain examples of a non-conventional energy processes based on a thermal energy, which will be used heat energy or thermal energy to remove the material from the workpiece. If you are considering the chemical and electrochemical processes, like whatever the process we have studied earlier, this will be the workpiece. This will be the type of the chemical or electrochemical process, that is the electrochemical machining, where chemical machining CHM, and also it also another type of this machining, that is the photochemical machining PCM, right? To remove the material from the workpiece, you require the working medium, that is the electrolyte, and the material is to be removed because of the ions, and that ions are to be produced because of a electrochemical dissolution process, right? Means in case of a electrochemical machining process, the material from the workpiece is removed because of the iron by using a medium electrolyte, and that ions are to be produced because of the process of electrochemical dissolution. Similarly, in case of a photochemical machining or simply chemical machining process, the material from the workpiece is to be removed by using the ions in a medium of the etchant, and that ions are to be produced by the chemical dissolution process. That is the chemical machining or photochemical machining. Are you getting this? समजतंय का? केमिकल मशीनिंग किंवा इलेक्ट्रोकेमिकल मशीनिंग मध्ये वर्कपीस कडून मटेरियल काढलं जातं बिकॉज ऑफ बाय युजिंग दिस आयन, अँड दिस आयन्स आर टू बी प्रोड्यूस्ड बाय द प्रोसेस ऑफ केमिकल डिझोल्यूशन और इलेक्ट्रोकेमिकल डिझोल्यूशन. And in case of electrochemical machining, you require electrolyte solution as a working fluid. And in the case of the chemical machining or photochemical machining, you require the etchant in order to carry out the chemical reaction with the material of the workpiece. That will be act as a working fluid in case of the chemical or photochemical machining. Draw the block diagram. Okay. This will be the short description for this slide. In chemical milling or photochemical machining process, we are using the chemical dissolution action to remove the material from the workpiece by using the ions which are present in each end. In electrochemical machining process, we use electrochemical dissolution phase to remove the machining or to remove the material which will passing through the electrolyte solution. This is thermal energy. In thermal machining process, material is to be removed by melting or vaporization of the workpiece. Also, we see the mechanical machining process, right? So, in this way, we are classifying the non-conventional energy process machining processes based on energy. First one, non-conventional energy process based on mechanical energy. It includes abrasive jet machining, ultrasonic, water jet machining. Thermochemical or thermal energy, it will include ion beam machining, electron beam machining, plasma arc machining. So they are required the heat energy to remove the material from the workpiece. Electrochemical machining. Okay. In electrochemical machining, it will require the combination of the energy, electric energy as well as chemical energy. So material is to be removed by the process of chemical reaction as well as electrical energy. EDM, ECM, these are the certain examples, right? In chemical machining process, we require the etchants or acid to remove the material from the work. So this all about the classification of a non-traditional process that we have discussed in today's lecture. If you have any doubt, feel free to ask me. समझ लगा classification? Are you getting classification? Okay. Now I am requesting to you all write your roll number in chat box for the attendance purpose.